Hassler here. I'm going to work through the 8.2 Explore. So visitors to a popular gaming blog are invited to subscribe to a newsletter for gaming news, reviews, and tips. The number of subscribers t weeks after launching the blog can be modeled by the function s of t equals 27 times 1.035 to the t. Okay, so a couple things I noticed is that I have this function. It looks to be exponential based off of the model that we talked about yesterday. That model where we had f of n is equal to f of 0 times r to the n. And they tell me that this time I'm talking about t, though. So t weeks after the launch. Okay, so that's going to be important. All right, so how many subscribers are there when the blog first launched? And when the blog first launched, that's really when time is 0. They're asking about the initial amount. So there's a couple ways I can think about this. I can say, okay, instead of f of n, I'm going to do s of t being 0. Time is 0. 27, 1.035 to the 0. And if I calculate that, I just get 27. So it really fits that when that time is 0, that initial amount, that coefficient that we had yesterday in our equation is really matching the coefficient in this equation as well. 2 says, is the number of subscribers from week to week getting bigger or smaller? And how many times bigger or smaller? Explain your thinking. So we know what s of 1 is. Let's do we know what s of 0 is. Let's do s of 1. And if I do that, I get about 27.945. So 27.945. Let's do s of 2. So I'm going to put 2 in here. And if I calculate that, I get 28.92. So it looks like they're getting bigger. But I went from 27 to 27.945 to 28.92. It doesn't look like I'm increasing by adding the same amount. It looks like I'm multiplying by something, which makes sense because we have this exponential. And so my multiplier is this number right here. So bigger by that r value, okay, or that multiplier 1.035. I can double check that. I can take 27. And so in Desmos, I can do this calculation, right? I can say 27 times 1.035. Oh, and I get the 27.945. So that makes sense. Okay. 3 says, how many subscribers are there after 10 weeks, 20 weeks, and after a year? Okay, so I'm going to do S sub 10. I'm going to do S sub 20. And how many weeks are in a year? Let's see, 52 weeks in a year, right? So I got 52 weeks in a year. And so I'm going to do S sub 52. Now listen, I can type this all in and do this calculation, or I can use Desmos. And if I use Desmos, I can type in that function that they gave me, right? So I'm going to type in S of t. I'm allowed to do that. Desmos will take capital function letters in t equals 27 times 1.035 and parentheses to the t. And then I can create a table, right, by going to the settings menu. I'm going to choose table. And it has a table created for me. So 1 and 2, then 0. Those match my values I had for problem 2. But for problem 3, I want to type in 10. I want to type in 20. And I want to type in 52. And so by typing those in, if I have my function and I type these input values into the table, it's automatically going to calculate the output values. So it looks like we have about 38. If I round the next one up, I get about 54 and then about 162. So I'm going to take these numbers, I'm going to write them over here. So it looks like I have, I did not mean to do that. All right, it looks like I have S of 10 was 38. And S of 20 is 54, about, right? And 1 year, so I'm not putting 1 in here. T does not equal 1. T is equal to 52. So you have to be careful what you're putting in. And we had about 162. Okay, so again, I can use the table to help me get that information. Okay. All right. 4 says, does the number of subscribers increase by the same amount each week? All right. Well, let's take a look. Back up here, I had S of 0 was 27, and I had S of 1 was 27.945, and then I had S of 2 was 28.92. And we already said these aren't adding up by the same amount each week. It looks like I'm, adding 0.945 and then 28.92. So not quite adding 1. It's kind of close. But let's take a look at our change here, right? If I think about this in terms of like X and Y values, and I make a table like we have in Desmos, I can think about this in terms of change in Y over change in X, 52, 162, right? So I can say my change in Y here is going to be 16 over my change in X here, which is 10. And so 16 over 10 is 1.6 versus this change in Y is 108. And that change in X is 32. And 108 over 32 is 3.375. So that tells me that these are not a constant rate, which means that this is not linear. Oh yeah, and by the way, the equation that we have, is geometric, right? I'm multiplying to get my new number each time. Okay, the next one says that we want to evaluate S of 42. All right, so S of 42, and explain what this number means in the context of the problem. Well, you know what? I'm just going to go over to Desmos, and I'm going to type in 42. We get about 115. We'll round that, so about 115. Okay, 115. All right, so let's go back up and think about this. This is my input. Oops. This is my input. This is my output. Let's come back up and read this description. The number of subscribers T weeks, so T is my input. T weeks, that's my input. So input is the number of weeks after launching the blog can be modeled by this function. So number of subscribers, that's my output, is modeled by this function. Okay, so with that being said, this would mean that after 42 weeks, there are 115 subscribers. All right, is it reasonable for T to be a negative number? So again, T represents weeks. And so no, you are not going to have negative weeks. Or weeks before launch, right? Negative weeks would be weeks before launch. But I'm not going to have subscribers before I launch because they don't have the information in order to subscribe. So it does not make sense to have this negative T. All right, so let's go ahead and take some quick notes on the next page. And let's see. We're talking about geometric sequences. That's what we talked about in the last lesson, and we're really still talking about that. Geometric sequences are exponential functions. So are examples of exponential functions. In other words, we multiply by a common ratio. In order to create terms in that function, okay? And so when we talk about general forms, all right, so general equations, general forms of equations. Yesterday, when we talked about geometric, we wrote the equation as f of n is equal to f of 0 times r to the n. And this was my initial, and this was my common ratio, my multiplier. Call it a multiplier. Similar story though, when we talk about an exponential function, it's the same thing. Only we use y instead of f of n, or we use s of t, or we use w of t, or we use whatever function they decide to use. Often we'll see this as a times, it's a terrible a times b to the x, or to the t, whatever input value they want to use. But again, this a is going to represent the initial, just like yesterday, the 0th term, okay? And this is going to represent our multiplier, or our common ratio. Okay, and one last thing, in order to get this common ratio, or in order to get this multiplier, same thing, number you multiply by or your common ratio, what you have to do is you have to take a term and you divide by the previous term. We've talked about this in the past, but it's been a while. Okay, so this is a little bit of review. All right, so your job is to work through the check your understanding and the 8.2 practice. And if you have questions, let me know.